Algebra 2B, Lesson 16.2, Solving Exponential Equations. Example 1, Solving Exponential Equations Algebraically. So the goal here is to get, we have to solve for this variable out front. So in order to do that, we have to isolate e raised to the 4x, and then we can use inverse properties to get rid of the e, but the first thing we have to do is get rid of 5 on both sides. So divide both sides by 5. 2 equals e raised to the 4x. So the inverse of e raised to the 4x would be the natural log. So if we take the natural log of both sides, that allows us to put the 4x out front. And the natural log of e, that will cancel out and be 1. So now we have ln of 2 equals 4x. Divide both sides by 4. We get ln of 2. Make sure when you put this in your calculator you close your parentheses. Divided by 4 equals x. And when we put this in our calculator, we get 0.173. So the next problem, we have to get rid of anything that's multiplied or added or subtracted first. So we add 4 to both sides. 5 raised to the x equals 11. Now we can take this one, it doesn't matter if we take the natural log of both sides or the log of both sides. So I will take the log of both sides. Now we can move that x out front. Divide both sides by the log of 5. And when you type this in your calculator, you get x equals 1.489. The directions today say round to 3 decimal places. Okay, next problem, we have to get rid of the plus and minus first. So the first thing we're going to do is subtract 5 from both sides. Now we want to get rid of the number that's being multiplied out front. So e raised to the x minus 1 equals 37.5. Now we can take the natural log of both sides. This allows us to move the x minus 1 out front. The ln and the e are going to cancel out. This whole thing becomes 1. So we have x minus 1 equals ln of 37.5. Add 1 to both sides. So when we type this in our calculator, make sure we close our parentheses after 37.5. Otherwise it'll include the plus 1. And that's going to equal about 4.624. This next one, there's nothing on either side, so we can just take the log of both sides. There's no plus or minus or anything to divide or multiply, so log of both sides. We can move the 3x out front. And now, because all of these terms are multiplied, we can divide both sides by 3 log of 6. When you type this in your calculator, make sure you do log of 12 divided by the quantity 3 times log of 6. This one, x equals 0.462. So this problem is going to use similar properties to solve. We're going to have to solve for the exponent, so we're going to have to do inverses, logarithms on each side, or the natural log on each side to solve for that variable. So we want to know how long it will take $250 to increase to $500. So the amount we want it to be is $500. The initial amount was $250, and then the equation was 1 plus the rate, which is 0.045 divided by 4, and then we're going to solve for n. First thing we want to do is get rid of the 250 outside. So 2 equals, and now I'm going to simplify what's inside the parentheses, and it'll be 1.01125. And now I can take either log or the natural log of both sides, doesn't matter which one, because I didn't give myself enough room. I'm going to use the natural log here. So ln of 2 equals, I can move the variable out front now. So now I divide both sides by the ln of 1.01125. And then I get 61.96. So this answer is, if it's compounded quarterly, this is the number of times it's been compounded. So 61.96 quarters, or if we divide that by 4, it will be 15.5 years. So this one's just like the previous one, except for instead of it doubling, it's going to triple. So we'll take the 250. We want it to triple, so it'll be 750 equals 1 plus 0.045 over 4 raised to the n. So same process as the one before. We have to get rid of the number out front first. 3 equals 1.01125 raised to the n. Take the log or the natural log of both sides. Divide both sides by ln of 1.01125. And we get 98.2 quarters, which would be about 24.56 years if I divide that by 4.